Cody, you just copy mine.
That's me, buddy.
All right.
Okay. Today, how are we? Just a bit chilly in here, yes? Tomorrow's her birthday. Yes, thank you for remembering. Today we are continuing our journey in physics into waves. So whatever you take notes on, get those out. Let's go. Let's roll. Let's roll. You can call today's notes. Do the wave.
Hey, Mr.
Yes.
For the vocab, I only had 32 words,
Okay.
and not 34.
I might have counted wrong.
Yeah, I only have 32.
Okay.
So do tomorrow.
They're due tomorrow. So, to get us in the wavy mood, let's do a little brainstorm.
Are you sure there's 30 words?
Someone said there's 32. Let's try to brainstorm. List of waves. If you can think of a wave, raise your hand. Raise your hand if you can think of a wave. Joel, give me one. Ooh, UV. Okay. UV, that's one. Who else can give me a type of wave? Yes. Sound. Okay. What else? Keep them coming. Warm up those brains. Ooh, mechanical. Someone's been doing their vocab.
Sure have.
Mechanical. Ocean. What else?
Electrical.
Electrical. Well, that would, okay, let's put electromagnetic. Electromagnetic. That would cover a lot. What else? Yes.
Solar.
That'd be UV.
Microwave.
Microwave. That'd be electromagnetic,
Microwave.
but it is a type of electromagnetic.
Do we have a quiz tomorrow?
The quiz is not going to be tomorrow. It's going to be Monday or Tuesday. Vocab quiz Monday or Tuesday.
Could you choose that?
Yes. That is electromagnetic as well. What about this wave? The high wave. Okay. What about this wave?
Like stadium.
Airwave.
The wave. Stadium wave. All right. Stadium wave. Who said brainwave?
Me.
That would be electromagnetic as well. Those are actually electric waves. Okay, that's a pretty good list. Yes.
Isn't light?
Light's electromagnetic as well.
Radiation wave.
Radiation. Let's write it down. That's a little different. It's a little different. Okay, good. That's a good list. Are your brains melting? Are they defrosting a little bit here? What? Emo wave?
Emo.
That's like a stadium.
Okay. So let's define what is a wave.
Oh, wait, no, we already got it.
So the definition of a wave is a disturbance. What is a disturbance? Something that
Goes out of place.
goes out of place, messes with something, changes something. Yes. That carries energy. Put a box through energy, around energy, not through it. Through matter and space. A disturbance that carries energy through matter or space. Why? What's that? I know. And the matter that it travels through is called a what? This is also a vocab word.
Medium.
The medium. Yes. The matter it travels through is called the medium. The matter a wave travels through is called the medium. Okay. So let's talk properties. So properties of waves. I put a box around energy for a reason because that has something to do with the first property. If you have energy, what can you do?
Work.
Yep. First property, can do work. Waves do work.
Yeah.
Game day. Game day. The turf is looking good. I saw it. It's cool. Very cool. What else? What else do waves do?
Move.
How? You're on the right track.
They dance. They bounce.
Yes?
They peak and then they peak.
They like
You're talking about shapes. What are waves caused by?
air.
Usually caused
Gravity.
by what type of object?
Air.
What's the object usually doing?
Yeah.
Usually a vibrating object, right? There has to be something vibrating in order to make it happen. So for like us, we didn't have a tsunami up here, right? All right, what's the vibration that causes that? The Earth's crust, right? What's the, what'd you say? Yeah, that would be the vibration that causes that. What's the vibration causing my voice? Vocal cords, right? You got it. Quantum mechanics. I love that you're just yelling out random words. What else do waves do? How is the wave different here than when it gets to Joel from my voice?
It dissipates.
Echoes.
Another word for dissipates. Waves do what?
Disappear.
Hold up, let me think.
Speech didn't change.
Fade.
Shrink.
Waves do what? If I fart right here, all right, who's gonna smell it first?
You.
No, I won't smell it.
Oh my goodness.
Caleb. Okay, who's gonna smell it last? Joel. Why?
I don't think it'll get that
What if
far.
it doesn't get that?
What are waves? It might not. I don't know how pungent my gas is today. Okay. All right. What'd you say? Yes. Waves spread out. Waves spread out. Waves spread out. What else? I think that's pretty good. They can do work. They cause vibration. They can spread out. Yeah, that looks good. Okay, let's talk about two types. You should have learned about two main types yesterday. The first type, somebody said it already, is mechanical. So, a mechanical wave needs what? No. No. If you're a mechanical wave, what must you have?
Motion.
Requires a medium. If you are a mechanical wave, you must have a medium to go through. What would be an example of a mechanical wave? Ocean, sound, right? High wave, there's the medium, all right? I can't say high without my what? Hand, all right? The wave, right? What's the medium for the wave?
Everyone.
The people. You see the Guardians walk yesterday?
You know who's there?
Who?
Porter.
I saw that. That's very cool. The other thing about yesterday's game, that would have been a boring game to be at. Like pitcher's battle. I also heard it was like 35. That's cold. 35 with the wind sitting in that stadium.
Yeah, that would stink.
Sheesh. It's crazy. The second main type of wave, we had brainstormed it, is guess what it doesn't need? Yeah, so which one is that? Electromagnetic. Electromagnetic waves. Electromagnetic waves don't need a medium, which means they can travel through a what?
Vacuum.
Yes. Don't need a medium. Can travel through a vacuum. And then we'll eventually talk about that in a little bit more depth. They all travel at the same speed. Anybody know what the speed they travel at is? Speed of light. We'll get to that probably tomorrow. So that's the two types. Let's talk shapes. Oh, I'm getting this is fancy. Look at this. Do you see this? Oh,
Their shapes.
yeah.
I'm so proud.
Let's talk shapes. Let's talk shapes. What is that? Is that a hexagon?
Yep.
Or is that an octagon?
It's not.
Ooh. It's an octagon. I did not think I would draw an octagon to get today, and I feel very, very special about my octagon I just drew. First shape. I bet this is a vocab word. Did you guys define a transverse wave?
I'm not done.
Yeah, I did.
Okay.
I don't know.
Transverse wave. A transverse wave is wave where the particles move perpendicular. I don't know why I decided to write that out. I could have just drawn that. You guys would have known what that was, right? Yes? Where particles move perpendicular to the wave, to the motion of the wave. Who wants to try to show me with their hand, arm, what that would look like? What would a transverse wave look like? Not necessarily.
That would be more parallel, wouldn't it?
Brielle, do that again.
Check two.
Okay. All right. What are you doing, making a butterfly? Float like a butterfly, sting like a bee. All right, here's my wave. Which way are the particles in my wave moving? Up and down. But which way is my wave moving? To the left. Well, to your right. Yes. All right. So, particles are moving up and down, but the wave is moving the other way. Do you guys see it? Yes. So, if we were going to draw that, it would look like this. That's a transverse wave.
So like an ocean wave.
That'd be a transverse wave. You got it. Also light.
Or
A high wave would not be.
No. Sound waves are the second type.
But couldn't they be like?
High wave?
No wait, on like a
Wait,
sound thing.
Sound waves are the second type.
But you could be hitting one of these and going up and down.
Second shape is longitudinal. Did you guys define that?
Yeah, I did.
Okay, good. Longitudinal is where wave particles, guess how they move?
Parallel.
Move parallel. Are you guys okay with the railroad tracks? Yes?
Yeah.
Okay. Move parallel to the motion of the wave. This one is a little bit harder to draw in the air.
So would it be like what I was doing?
Do it again.
Parallel?
No, but do you do that with a windshield wiper, which is cool.
I
Anyone else want to try?
What is?
Okay, do that again, Nigel. Okay, close. All right. But it looks like your wave, you're going to have some particles doing some kind of vibration, right? Ooh, Brielle. Okay, that's... Brielle looks like she's getting ready to do some karate. All right. This is how I like to think about it. All right. All right. It's kind of going like this. All right. Also, have you ever seen a slinky? Right? If I had a slinky and I gathered up some springs in my slinky and I let them go, would you see it go through the slinky?
Yeah.
Yes. All right. So I like to draw it like this. Here is a longitudinal wave. Are my particles moving to the right? Is my wave also moving to the right? Yes. So they can be close together or they can be far apart.
That's not going to be used.
That's a longitudinal wave. Kind of like a slinky.
The more you pull your slinky, the more it's like cursive eyes.
Yes. Guys, my daughter got a slinky for Christmas.
You may go downstairs.
How long do you think it made before it got tangled?
2 seconds.
1 hour. And then she cried.
Oh.
I'm like, I told her, yeah. I'm like, you got to be really careful with that slinky. It's really cool, but it's going to get tangled. She's like, it's not going to, Dad. An hour later, she's like, it's tangled. I'm like, it's ruined. So,
Wait, the metal ones like bend.
yeah, they bend. Yes.
One was last year with Spencer and she yelled at us for like days.
Yeah. Yeah, slinkies are wild. Third type, the third shape is called a surface wave. These are crazy, all right? Because surface waves don't move longitudinal, they don't move parallel, they move both ways. It's a combo of both. All right, Brielle, you've been on for this. So draw that in the air. What's that going to look like?
You said box combo.
No.
Oh, is it gonna be one of these?
Oh, there it is. CPK got it. All right. It's moving up and down and right to left at the same time. All right? So that is a surface wave. Are you going to see that in the ocean? All right? Ocean is a type of surface wave. All right? It kind of rolls, right? That's how you can pick up sand and move it. So those are your 3 types of waves. Look at that. See? Science. Science. Okay. Let's talk now. Put a little through your notes right there. Let's talk period versus frequency. Period versus frequency. So, first thing we should probably do is define each one of these words. So, first of all, let's talk about period. Have you guys defined period yet? Yeah. Okay. So this is the amount of time, right? Yes? Yep. So time is measured in seconds, all right? It takes for one, underline the word one, full wavelength, for one full wavelength to pass a certain point. To pass a certain point. Is it a game?
Yeah.
I have not played it. Symbol. Guess what the symbol is? It's going to blow your mind.
A period.
No. It's not. Symbol is T. Units is seconds. It can't be P. Why? We're going to use that for momentum. So now we're just recycling stuff at this point. All right? Because period is essentially just time. Just time. I am out of space, so I'm going to move my screen. So I'll wait for you guys to catch up. I'm going to hydrate while you guys are catching up. Hydration break. I'm very hydrated today. This is my second bottle. Yeah. It broke. But it still lights up.
It broke already.
I dropped it 3 times.
Ava, tell about your water.
What happened?
Oh, I saw that. Oh my gosh. Hey, she landed it though.
Hey, let me tell my story.
Yeah, let her tell her story.
I was walking down the steps and then I was going to run into Ella, so I like moved to the side and then I dropped my water bottle and it went down the whole flight of stairs and the top broke off and all the water went all down all the steps and then we had to put the caution sign up and then my wall broke, so.
It broke.
Did this just happen?
No, it happened after 6.
Did you let someone know so like no one dies on the stairs?
No, she ran. She picked up the water bottle and flew the scene.
Wow.
They put the caution sign up.
I heard a crash and I turned. Wow. Yeah, I turned the corner.
I'm so sorry. Rip your water bottle.
And her water bottle landed in the wallet.
It landed?
And the lid.
Like up?
The cap was like facing up, and then the bottle was like.
Okay.
Everybody just stared and then
All right.
The entire stairs, how much water was in that wallet?
I'm so sorry. I would have just scrambled to help you if I would have been there.
Like water bucket.
It's okay. I didn't.
We caught up? Okay. So that's period. Let's talk about frequency. So, same section. Frequency. Frequency. I don't know why I just spelled that out in my head because I was thinking, I guess. All right? Frequency is the number of full wavelengths. So we're no longer talking about just one wavelength. Now we're talking about multiple wavelengths that pass a point per second. Underline per and underline second. Symbol is F. I know. Blows your mind. Unit is a per second or a 1 over a second. But we don't write a per second or a second to the negative 1 or a 1 over a second. What do we write? It's hertz. So the unit for frequency is hertz. Units for frequency is hertz. What? Hertz. HERTZ. Frequency and period are inversely related. They are inversely related, which leads us to an equation triangle. All right? So here's my equation triangle for this. Pretty much. I've got the number 1, I have T, and I have F. So T is measured in seconds. Frequency is measured in hertz. So that means that T equals 1 over F. Agreed? Or F equals what? 1 over T. F equals 1 over T. The other thing that you may sometimes see for frequency is frequency put in parentheses, the number of vibrations per second. That's another thing that you may see sometimes. So besides this, the other ways you can solve for frequency is also the number of cycles per second. Sometimes you'll see that. So like if I'm going back and forth 2 times, right? In 1 second, my frequency would be what? 2 hertz. You got it. Number of cycles per second. So if I was solving for period, T, what would be the opposite of that? Or the inverse of that? Number of seconds per what? Per cycle. Number of seconds per cycle. So, is that on your blue sheet?
Yeah, probably.
I'm not sure if that is on your blue sheet, but check to see if it is. We got a blue sheet handy? That is not on your blue sheet. So, you're going to want to make sure that you... Is it?
Yeah, it's on the equation.
Oh, here it is, wave equations. Yes. So T, look at that. Seconds per cycle, F cycles per second. Cycles per second. Tonight, you have a pretty quick assignment to do. You'll probably finish it in class. This is frequency and period. You'll finish this in class. This should not add to your homework. What number do you want to do together? 7. All right.
You're gonna do 7, you got it. What about 11? I think 8 or 11. Yeah. Definitely 11.
All right, let me flip to my screen. I heard 7.
No, you heard 11.
Yeah, I heard 11.
Heard 11?
Yeah.
Oh, snap. Oh, this is crazy. Okay. A wave has an amplitude. Oh, I'm going to have to draw this thing. Okay. So let's draw a wave. Okay. This is a little bit tricky because we haven't talked about amplitude yet.
So I said,
But guess what? That doesn't matter, right?
We know what amplitude is.
It's just saying what's the period, right? What's the equation for period?
Period equals 1 over F.
T equals 1 over 12 hertz. That's it. What's 1 divided by 12? Put it in your calculator. What?
we have to use decimals.
Got to use decimals. We don't do fractions. Thank you. So T equals 0.083 seconds. 0.083 seconds. So does that make sense? If I take a 1 divided by a 1 divided by a second, right? 1 divided by a 1 divided by a second is a second. Because you take the inverse, right? These are all easy like this, guys. Don't overthink them. I started with 2. I ended with 2.
That's 3.
Nope. Starts at the first non-zero digit.
I thought it was 5.
Work with the partner. Finish that up. If you finish that, you can work more on your vocab.